Welcome everyone, and we'll kind of kick in here to my talk on cross-chain. All right, let me move my windows a bit. Great. So as I mentioned in the opening remarks, really the specialization of Moonbeam is on these new kind of cross-chain like applications and kind of specializing in supporting cross-chain use cases. I think I want to dig in on this and kind of talk about some example scenarios so that it can kind of make it a little bit more concrete for people, like what's happening. And you'll be hearing from some of these teams later, like in the in the next couple days. And so one piece of context that I'd give, and a way that I frame things for people in how I'm thinking about things, is this kind of historical analogy, right? I'm big on the history of technology. I use it often to think about like what's happening or what will happen, right? I look for kind of historical patterns, right? And there's this saying that Mark Twain has about history not repeating but rhyming, right? So it's never going to be exactly the same, but there's certain patterns that are the same. And for me, there's this very strong connection between the history of general compute, just like how computing has evolved over time, and how I expect blockchains and Web3 infrastructure to evolve over time. And so I have these two timelines here where in the history of compute, you started off with computers being very, very expensive, right? There was very few of them. As a result, the resources like on those computers were very scarce. And then a whole set of features were designed to help users share those resources. And so that's almost, I think that's the era that we're still in some ways, right? There's certain blockchains like let's say Ethereum mainnet or Moonbeam. The resources on those blockchains are scarce. A lot of users are sharing like those computers, right? You can think of a blockchain as a community computer. And it's really just now that we are moving into the idea of app chains, right? So which I think are similar to PCs, where instead of sharing a computer, you have your own. And so app chains are really an expression of that idea in the blockchain world, where you have an application that's going to have its own blockchain supporting it versus being on a shared system. And I think that the moment that we're in right now is all of these chains that exist, app chains and other shared smart contract platforms, are being networked for the first time, right? They're able to send messages to each other. And that's just happened this year. I mean, this is what people don't realize is, all this is quite new. And, many of these cross-chain interoperability technologies have just come out this year. And, so this is just a new design space that's already, moving very quickly, where people are taking advantage of these new cross-chain like interop protocols to be able to create new kinds of application architectures. And ultimately, I do think that things will move in the direction of the cloud, right? Where as a developer, you'll be able to get the resources you need to back your application more as a service, right? So only use as much as you need. So that's kind of the context and trends for what I'm seeing and how I expect things to evolve. And so in that context, Moonbeam is specializing in what we call connected contracts. So that's the idea that a smart contract on Moonbeam can reach like any user, asset, or service on any chain using these new cross-chain interoperability protocols. And there's a whole bunch of them that are now integrated onto Moonbeam. And you'll be hearing later in this next 2 days about from several of the prominent teams that have built these cross-chain interoperability protocols on how they work and how one can use them. And I think in terms of Moonbeam and how we're able to support this idea of connected contracts, one key point is to integrate as many of these cross-chain interoperability protocols as possible. We have native access to XCM, being a parachain on Polkadot. That's one cross-chain messaging system, but there's multiple other systems that are integrated to Moonbeam these days. So just to rattle off a few, that would be folks like Axelar, Layer 0, Wormhole, Hyperlane. There's a number of protocols and other ones that are up and coming as well. And so we really want to give the maximum amount of options to developers in terms of being able to integrate like with other chains. And we couple that with the EVM-based development environment on Moonbeam, and there's really has been quite a bit of effort, and there's a lot of tooling and infrastructure that's been deployed around Moonbeam to create a very familiar and good like development environment including things like Etherscan as like a block explorer, and many other tools and integrations that people expect when they're operating in an EVM environment. And then this last point around securely scaling through specialized resources, I'm going to talk about that a little bit towards the end of my talk. That this is an area where I have a lot of new ideas around how this will work, and the idea is that really Substrate and Polkadot provide this like great platform upon which new kinds of blockchain-based resources can be brought to bear. And I think it all ties in with this connected contracts vision, where smart contracts and Moonbeam may leverage then these specialized services and use them as a scaling path, to scale up their applications once there's an increasing number of users on them. And so we'll talk about that a bit later. So just to set the stage, what are the current approaches to multi-chain, and what are some of the challenges with them? So I'd say that right now, in the first wave of multi-chain deployments, it's really what I'd call a multi-instance deployment approach. And so what does that mean? What that means is that if you have a protocol that was looking to deploy on 5 different chains, well, you would have 5 different instances of the smart contracts of that protocol, and really just 5 different separate instances of the protocol, right? So you might have a set of smart contracts deployed on Ethereum mainnet, those same contracts on Polygon, those same contracts on Moonbeam, those same contracts on BNB chain. And so each one is operating as kind of an island, on the chain that it's deployed to. And so I think the main challenge, it obviously works, so you get to all the chains and you can service users on each of those chains. But the drawback is really this challenge of fragmentation. So, when you take this approach, different, the things happening on one chain really have no bearing on what's happening on another chain. And as a user, you have to be aware of which chain you're on. And if you want to move, for example, from one chain to another, then you're probably in the realm of withdrawing from the protocol, using a third-party bridge to move assets from one chain to another, and then re-onboarding them into the instance on another chain. So it's kind of this huge like fragmentation of the user experience of in the context of DeFi, being able to have liquidity in a protocol, and that gets fragmented. The features get fragmented. So there is this kind of challenge of fragmentation that comes with the existing approaches. And so to give an example of like a new approach, and you'll be hearing later on in the next couple of days from Colton over at Prime, but I use this as a good example of the architecture of a new approach that uses cross-chain messages to do something novel and different. And so the approach here that Colton and Prime have taken is around creating a natively multi-chain architecture. So it's a hub and spoke architecture where you have a set of contracts deployed on all of the chains you want to deploy to, but they're connected together. So it acts as one system versus acting as n number of different systems. And so there's a set of master smart contracts, let's call them, on Moonbeam as the hub. And then you have, let's call it, remote satellite deployments on a bunch of the other chains like Ethereum, BNB chain, and so on, a number of other chains. And then the idea with Prime is that users can interact with the protocol on any one of those chains, but information flows back to the center so that a deposit that a user does on one chain can then be leveraged or used on another chain, and it's all acting as like one system, with kind of a headquarters, deployment location, and then branch offices, almost like that kind of idea. And I think so. This is like a very powerful idea. It really cuts back at that challenge of fragmentation, right? It unfragments the system from a feature perspective, from a liquidity perspective. And I think that this means that that Prime, in a lot of ways, will be competitive against protocols that take a island or kind of like a separate deployments approach, like I was describing. A lot of protocols do these days. I want to just give another example of cross-chain and a key benefit of it. There is this collaboration that has been used Moonbeam or connects Moonbeam back to Osmosis. Osmosis is a Cosmos SDK-based DEX app chain. And what they wanted to do was to power one-click dot deposits. And so how that works is the end user is given like a native dot address as a deposit address. And then there's a lot of different steps that are kind of hidden behind the scenes. So behind the scenes, when a user deposits into that native dot address, there's a series of moves. So that dot is moved to Moonbeam via XCM to be XC dot. On Moonbeam, it's forwarded to Axelar, to route from Moonbeam over to the Cosmos interchain. Then there's a leg that moves it onto Osmosis, and then there's an LP action that's triggered on Osmosis. So there's a good 7 or 8 steps that are happening across multiple chains in the background. But the key point here is that the users don't need to know about that, right? So all that complexity is hidden away from them, and they're offered this very simple user experience. So I think that this is I like this example because this is another great power of this cross-chain connected contracts idea, is that you can make better user experiences. You can make simpler user experiences and hide away the complexity, the infrastructural complexity from end users. That's something that Web 2 is really good at, and I think that's something that will be a big unlock for Web 3 based applications to start to do similar techniques, using these cross-chain messaging systems. And so I wanted to come now to a little bit of a preview of some thinking that I'm doing around something I'm calling containerized app chains. And so it kind of goes back to the original idea that I mentioned, where Moonbeam has this very great development environment, this EVM environment that has all these tools and integrations around it. It also has a number of different cross-chain protocols that are integrated with it. But the question is how do these apps scale, right? And there is this growing demand these days for app chains. If you look over the last couple years, there's a huge number of app chains that have launched, and I'm looking even just specifically at 3 ecosystems: Polkadot, Cosmos, and Avalanche. Right, so even just across those 3 ecosystems, there's a huge number of application-specific chains now that have launched. And you can see pretty high-profile projects. For example, there's a project DYDX, one of the largest decentralized derivatives protocols out there. They started off on Ethereum mainnet. They then went to an L2. They went to Starkware as an L2 to scale their application, and then most recently they've announced that they're building an app chain. And so the question is why this kind of movement towards app chains? And I think there's a few key drivers for this. One driver is certainly around performance and cost, right? So whenever you're on a shared platform, if you have a significant rise in demand on that platform, that does increase prices then, and then the users of your app are going to get hit, right? So this is the whole, an NFT mint is happening, thus the chain becomes either slow or has usability issues. And so an app chain really is a way that you can have a dedicated amount of capacity that's devoted to your app and kind of protect the end user experience, let's say. And so I think that is a big motivator for people as they're scaling up and looking to service more and more users. There's a second driver around customizability that I think, again, as apps scale or servicing more users, really you want to be able to optimize the implementation, and having the ability to optimize at a low level really gives you a lot of flexibility then in terms of being efficient. And so I think that this is increasingly a driver for people to want that full control of an app chain, is this ability to customize and optimize the whole environment. And last but not least, I would say around value capture, there are opportunities for value capture that present themselves when you have an app chain where you have the token associated with your protocol is an L1 token, right? So it has it's providing security to the base chain, and things like staking and other functionality can be baked into it itself. And so I think these are all pretty big drivers for why people are choosing app chains. But there are challenges that come along with this, right? And so it's not for everyone. And I think the summary point would be that they're difficult to implement, right? They're challenging to implement. They come along with a bunch of infrastructure requirements, right? So you often have to bootstrap a validator set, or you have to create a set of block producers who are going to produce blocks for this thing. You're responsible for a lot of low-level things that you kind of get let's call it quote for free when you're on a shared platform. So that's a turn off for a lot of people going down this path. There is this problem of security too, where on an app chain, like the security for the chain is kind of mismatched with its utilization, right? So if you're just launching one for the first time, you don't have product market fit yet, you still are paying a huge amount for security, and the securities might not even be that great at the start because you have a small validator set, and the economic value of your token may not be that high, and so that it makes it vulnerable to attack. And I'd say the third area of challenge is around being on an app chain. You have this limited like composability and kind of fragmentation that happens, right? Because you're on your own. You don't have this like in the case of Moonbeam, like an EVM environment where everyone is composing via an EVM. And so these are all reasons why an app chain is kind of not an attractive option to people to developers. And so I think the concept that I've been thinking through is something I'm calling a containerized app chain approach. And so what does that mean? Well, it aims to make the like developer experience for deploying an app chain very easy. And so the idea would be that the developer would just supply the code related to the chain that they want to run. This could be kind of the blockchain logic, or using kind of substrate terminology, the runtime. Polkadot itself, just like on Moonbeam, could provide the security around the app chain. But there's a new capability, this container execution environment, which would provide a lot of the other services needed to make a fully functioning app chain. So this is an execution environment, supporting block production and maintaining like the state of the blockchain, so that that's available for new blocks to be created. And so I think that if this is done right, you'll be able to get a lot of the benefit of like this power of the app chain I just described, like this control over costs, this ability to scale, but like with the ease of use of something like a smart contract deployment on Moonbeam, right? So the dev doesn't need to worry about this low-level infrastructure as much. They just need to create the code and deploy the code. And so I think that this has like a lot of potential, like to unlock a very powerful capability, but then again still have this like ease of use associated with it. And I kind of just want to paint like a picture of this larger picture of like how this would all like fit together. And I've talked before about this idea of having almost a broader view even than just Moonbeam. So Moonbeam obviously is playing this critical role of being an EVM execution environment, of being an integration gateway, because it has all of these cross-chain protocols integrated to it. It has a great like local DeFi ecosystem in its EVM. But my broader view is that there's a whole number of services ultimately that need to be created to provide like a great developer experience that will allow them to like manage the full life cycle of their app and scale it up like as they have more and more users. So like in this context, Moonbeam and all of the services on it are obviously kind of this critical component, almost this like routing point, right? Where like all these cross-chain messages are coming in. And this app chain container system I'm describing, that can be the capacity, right? So as you need to do a lot of work, you'd be able to, on a spot or reserve basis, create like a dedicated app chain and process a lot of the transactions and work like on a separate chain. But of course, tie it back to services on Moonbeam, right? So they work together. And so this is kind of my broader vision, is to head towards this environment where it feels like a cloud-like experience where you have a number of different services as a developer that you can use to build your application, and they're all designed to work together. So think of it as almost like a product suite with individual products in it. And so this is the larger vision that that I'm thinking about these days, and I think that Moonbeam will continue to play this like very critical role in connecting all of these pieces together. And so yeah, that's kind of the broader view.